we can continue the question paper discussion of JU Main 2020, 9th January shift 1 question. So we discussed till question number 12. So we can just take the question number 30. Consider a force F is equal to minus xi plus yj. The work done by this force is moving a particle from point 1, 0 to b equal to 0, 1 along the line segment is. So we need to find what is the work done. But here the force is a variable one. So we have to use the concept of integration. So that is a very important concept. So how we can done it? So the simple concept, see, it is given that force is minus xi plus yj. So keep in mind, and here, if we just use the equation, here we can say that x1i plus here as y1j. So the position vector, and that for the concept we can written as x1i xi plus yj. So that means that value dx dy is moving like this one, dxi plus dyj. So if you know these two concepts, you can this equation we can use it, and that is f dot ds. So that is equal to integral minus xi plus yj dot s as dxi plus dyj. So we're going to combine that I vectors together. So that is equal to minus x dx plus integral y dy. The limits we have to take it. So that is from A to B. From A to B. So the x coordinate from 1 to 0. So 1 to 0. And the y coordinate from as 0 to 1. So we have to integrate. So you know we can integrate that x coordinate as x square by 2 between the limit 1 to 0 plus as y square by 2 between the limit as 0 to 1. So that is equal to 0 minus minus half plus 1 by 2 minus 0. So equal to 1 by 2 plus 1 by 2. So you get the value as 1 joule. So we can code that 3 as the answer. A good concept. Number 14. A good question. In the given circuit diagram, a wire is joining points B and D. The current in the wire is, we have to find. So we have to approach it so carefully, then only you get the answer. So the current is, we have to find what is the current flowing through that BD. So if we just consider as the normal one, we can just find what is the R effective of this one. So here we can easily say that 1 ohm and 4 ohm are in parallel, and 2 and 3 are in parallel. And hence for 1 and 4 in parallel, you get the effective value as 1 into 4 by as 4 plus 1 as 5. So that is equal to 4 by 5. So that circuit can be redrawn to be as 4 by 5. And here are 2 and 3. So 2 into 3 by 2 plus 3 as 5. So you get the value as 6 by 5. So 6 by 5. So that is connected to 20. So then what is the total current flowing through it? It is simply the total EMF division by the total resistance. As 4 by 5 plus 6 by 5. So 10 by 5. So that is equal to 2. That is equal to 10 ampere. So the very important concept is the 10 ampere is flowing from this one. That is the total current here. And suppose here it is splits into 2, and that we can say as I1, and here it is I2. But up to this one, you should know one thing, and that entering into BD part is nothing but the 10 ampere together, I1 and I2. But whatever may be the case, after BD, so there should be another, that value, it should be also 10 ampere. Say, suppose it is I3, suppose it is I4, then only together you get the value as I here. So that is a very important concept. So up to this one, so we can say that I1 and I2. But after BD, we can say that I3 and I4, but that I3 plus I4 should give I. That is nothing but as a 10 ampere. So based on that concept, we can say, so the very important, the potential across this much should equal to this much. So that is a very important concept there. The VAB should equal to, that is equal to VAD. So here is a 1 ohm. So 1 into I1, that should equal to I2, 4 into I2. So you get the value as I1 take the value equal to 4 times of I2. But we know the concept as I1 plus I2 equal to 10 ampere. We can substitute for this I1 as 4 I2. So we get the value as 5 I2 as 10 ampere. So I2 take the value equal to 2 ampere. And hence we get the value for I1 equal to 8 ampere. And similarly we can approach for this section also. So this I3 plus I4 should equal to 10 ampere. But keep in mind, if you just consider the potential across that BC, it should be equal to CD. That is a very important concept. So we can say that the potential across BC should equal to the potential across VCD. So BC is 2 into the current flowing there should equal to 3 into I4. But we know that I3 plus I4, that should be equal to 10. So you can just substitute for I3. So I3 is what? As 3 by 2 I4 plus I4, that is equal to 10. So that is equal to 5 I4 by 2 is equal to 10. So that is equal to I4 is equal to 20 by 5. That is equal to 4 ampere. Then what is the value for I3? So I3 is equal to 3 by 2 times of 4. So that is equal to 6 ampere. From that evident, 4 plus 6 is equal to 10 ampere. So that is a very, very, very important concept. So then look the figure. So here I3, that is given as 6 ampere. Then I4, that is given as 4 ampere. But we know that I2, that is given as here 2 ampere. Now here it becomes 4 ampere. So there should be a flow from B to D. It should be 2 ampere. So then only it becomes 4 ampere. So we're going to certainly say. So keep in mind here, 8 ampere is coming. So here it is 6 ampere. It flows as 2 ampere. So that is answer, 2 ampere. A good question, good question. Number 15. A long straight wire of radius A carries a current distributed uniformly over its cross section. The ratio of the field due to the wire at a distance A by 3, that means less than that of its radius, and 2A, another distance greater than that, from the axis of the wire. See, if you just consider one wire from the axis, if you just to find what is the value here at a separation as a 2 into A, you can consider that wire is concentrated along the axis and infinitely long one. The magnetic field at this point P2, BP2 becomes so easy as mu 0 by 4 pi into the current flowing through that 2I division by the separation. So that is nothing but equal to 2A. But here the another very important concept is wanted to find at a particular point here, say at a separation as R. So how we can find it? Here the radius is given as say capital R, but here it is A. So at first you have to construct an Amperian loop including that point under consideration. And here that current I is uniformly distributed from the 0 radius to the capital R, here A. And hence, for that cylinder, the current flowing is, say, I dash. Then the magnetic field at that point, P1, we can write as mu 0 by 4 pi into 2 I dash, that division by the separation as R here. But how we can express that I dash in terms of our I? So we know the charge density should be a constant one. That means for that A radius should equal to that for the R radius. So the current flowing through that A as I division by the area of cross section as a pi A square, it should equal to that for the small cylinder cross sectional, that is I dash division by pi into R square. So here pi cancel, you get the value for I dash is equal to I R square by A square. So you can substitute as equal to mu 0 by 4 pi into 2 by R into I by A square into R square. 1R cancel. So you get the value as mu 0 by 4 pi into 2I by A square into R. But our aim is to find what is the ratio. So you just consider between the contribution of 1 and 2. So here R is substituted with the concept of A by 3. So mu 0 by 4 pi into 2I by A square into A by 3. So here we just take the two conditions. Mu 0 by 4 pi into 2I by A. Mu 0 by 4 pi into 2I by A. So BP1 equal to BP2 2 times of BP2 that division by 3. So we can say as BP1 by BP2 is equal to 2 by 3. So you get the answer as 1. A good concept, keep in mind. So if we just draw the variation for that cylindrical wire to the magnetic field with the distance R, so the curve is like this one. It's a very good concept, keep in mind. See, number 16. A good question again. A vessel of depth 2h is half filled. So a vessel is here. It is a half with the refractive index of 2 root 2. So we can just take its h half and is filled with a material having a refractive index as 2 root 2. And the next half with another liquid with a root 2. So another half with a root 2. The liquids are immiscible. The apparent depth of the inner surface of the bottom to the vessel. So because of the two liquids in together, so the total apparent depth, that is a very important concept, is equal to the apparent depth contribution because of the one liquid plus two. So that is nothing but when the observer is in a rarer medium, we can simply say the real depth division by the refractive index of the first medium, that division by the refractive index of the second medium. So that is equal to, and here the real depth is h by 2 root 2 plus h division by root 2. We can take that h by root 2 in common. It become 1 by 2 plus 1. So that take the value as h by root 2 into 2 plus 1 as a 3 by 2. So you get the value equal to 3 by 2 root 2h. But there is no choice like this one. If you just multiply a root 2 on the numerator and the denominator, you get the value as 3 root 2h by 4. So 3 root 2h by 4, you get the answer as 3. 3 as the answer. Number 17. A very good question. 3 solid spheres, each of the mass m and a diameter d, are stuck together such that the lines connecting the centers form an equilateral triangle of side length d. The ratio I0 by IA, the moment of inertia of I0 of the system about an axis passing through the centroid and about the center of any of the spheres IA and perpendicular to the plane of the triangle. So any of the center, that is IA. So we have to find what is IO by IA. So at first one, and before coming, this is AC, that it is under considering a triangle. So this is D. And at first we have to find what is the centroid here. And so if it is a D, so comfortably you know the concept as this is the altitude and this is nothing but a D by 2. So H is what? So simply equal to root 3 by 2D. But you know, if it divides, that centroid divides in the ratio 2 is to 1, that altitude. So if one part is x, we can say as that 3x, take the value as root 3 by 2D. Therefore, the one part take the value as 1 by 2 root 3D. But we need from a corner to the centroid, the separation as 2x. So equal to D by root 3. So that is a relevant material we needed. So based on that, what is the moment of inertia about O? About O. So the three particles are on the corners. So that is with the separation as simply as D by root 3. So at first we have to find what is the moment of inertia of the sphere about C. That is its diameter. That value plus, by application of parallaxis theorem, you get the value at the point O equal to, with the 3 contribution, the center of mass value, that is 2 by 5, that is em into the radius square. The radius, here it is given as the diameter d, and hence we can say that as d by 2 the whole square, plus em into that centroid with the corner separation. So that is nothing but the d by root 3, that much square. So that is equal to 3 into as a 2 by 5 m into d square by 4 plus m into d square, that division by 3, that is equal to, we can take that m into d square in common, that is equal to 1 by 10 plus 1 by 3, and you get the value as 13 by 10 m into d square. So that is the moment of inertia about that O point. Then how we can find the moment of inertia about of the system about A? So got three contributions, and there we can say the moment of inertia of A about its diameter value, that is nothing but equal to 2 by 5 m into that radius square plus two equal contributors of B and C are there. But how we can find the contribution of B and C? At first, we have to find what is its contribution about B or C. That center of mass value plus m into the separation square. So the two contributions, the center of mass value is 2 by 5 m into d by 2 square plus m into the separation between A and C as mt square. So that is equal to 2 by 5 m into d square by 4 plus 2 into 2 as 4 by 5 m into d square by 4 plus 2 m into d square. On solving, you get the value that is equal to as a 23 by 10 m into d square. But our aim is to find IO by IA is equal to as a 13 by 10 m into d square by 23 by 10 m into d square. So you get the answer as 13 by 23. So you get the answer as 4. Number 18. A quantity, the given as f is equal to hc raised to 5 by g, where c the speed of light, g the gravitational constant, and h the Planck's constant, then the dimension of f is that. So at first you know what is the value for h. So you know the Planck's constant can be related with the energy as, so h is equal to energy by the frequency. So the dimensionally ml square t raised to minus 2 by t raised to minus 1. So ml square t raised to minus 1. So that is a value for h. Then we can substitute to find the dimension of f is equal to as a square root of the value of h is what? ml square t raised to minus 1 into c is what? C as nothing but L t raised to minus 1. So L raised to 5, t raised to minus 5. That division by the gravitational constant. We can use the relation as FGM square by R square. So you get the value for G as m raised to minus 1 into L cube t raised to minus 2. That is equal to root of that m can be taken in the numerator. You get the value m square. That much into L square into L raised to 5 become, that is become L raised to 7 by L cube. So L raised to 4 into t raised to minus 6 by minus 2. So t raised to minus 4. Then it become root. Then m L square t raised to minus 2. So that is nothing but what? Energy. So you get the answer as 1. Number 19. Consider two ideal diatomic gases A and B at some temperature, at the same temperature T. Then the molecules of the gas A are rigid and have mass m. Molecule of the gas B have an additional vibrational mode. So the ideal diatomic gases, additional vibrational mode have a mass m by 4. The ratio of the specific heats, we have to find the specific heat capacity at a constant volume for A and the specific heat capacity at a constant volume for B. So we have to find their ratio. And at the first one, and keep in mind, the energy related to that is nothing but equal to half f Faraday, where f is the degrees of freedom. You can find the specific heat capacity as first differentiating that potential energy with respect to the temperature is equal to half Fr. And here the first case, it is the ideal diatomic concept. For A, we can say simply is equal to F become 5, so 5 by 2 R. But for B, there is an additional vibrational mode, and hence we can write the value as 7 by 2 R. And hence we have to take their ratio. So CV by CV for A by CV for B is equal to as 5 R by 2, the 7 R by 2. So you get the value as 5 by 7. So you get the answer as 2. A good concept. Number 20. An electric dipole moment P is at the origin. The electric field due to the dipole is, and not that, R dot P, that is equal to 0 and is parallel to the electric field due to the dipole is parallel to, so, and also it is given as R dot P is equal to 0. So we can say that it is a very important concept as R dot P is equal to 0 means we can say the very important concept as E must be anti-parallel to P. That is a very important concept. Then only R dot P is equal to 0. So anti-parallelly we can say that E must be just multiplying a negative constant with P. That is a concept. So, and here it is given as the value of P is what? Minus I minus 3j plus 2k. So if you just multiply with the minus sign, it should be of the form as I plus 3j minus 2k. So that is a very important concept. So we know the concept. If there is a vector as AI plus bj plus ck, and we can that A is parallel to the electric field when that A by lambda should equal to B by 3 lambda should equal to C by 2 lambda. So that is a concept. So we can just use the minus concept of that P. So you get the answer as a 2. A good logical question. Number 21. Both the diodes used in the circuit shown are assumed to be ideal and have negligible resistance when these are forward biased. Built-in potential of each diode is 0.7 volt. For the input voltage shown in the figure, the voltage at the point A is what? But keep in mind here, that is a reverse biased one. So that means this potential is restricted to in this region. Here the built-in potential is there minus 7 volt. Okay, fine. That means we can say that the V inside is distributed among that diode plus that resistance. So 12.7 is distributed among the potential across the diode plus the potential across the resistance. So our aim is to find what is the potential across A. If you take the value of this one as 0, then we can say that the potential at the point A is equal to 12.7 minus the potential across the diode. On dot it is given as just 0.7. So you get the answer as 12 volt. So that is a very important question. A good concept as a 22. In a fluorescent lamp choke, a small transformer of 100 volt of reverse voltage is produced when the choke current changes from its 0.25 ampere to 0 in a duration of 0.025 millisecond. The self-inductance of the choke is estimated to be, the simple concept to evaluate the induced EMF, that is nothing but equal to L into di by dt. Our aim is to find what is L. So that is equal to E into the time in division by the variation in current is equal to the 100 into, it is given as that time as a 0.025 into 10 raised to minus 3 by the current changes from a s 0.25 to 0, so 0.25. So that we can return as a 2.5 into 10 raised to minus 3 by as a 2.5 into 10 raised to minus 1. So you get the value as a 10 raised to minus 2. So we can say is equal to 10 millihenry. So that is the aspect. So that is the answer. And keep in mind that questions from 21 to 25, for each physics, chemistry and mathematics, they are numerical type, not integer. Keep in mind the numerical type in any power may occur as a 23. A simple question, but good one. A body of mass m is equal to 10 kilogram is attached to one end of a wire of length 0.3 meter. The maximum angular speed with which it can be rotated about its other end in space station is, it is given the breaking stress of the wire and area of cross section. You know, it is rotated in a horizontal circle, and here now the centripetal acceleration, that mr omega square, that is nothing but given by the tension. The correspondingly we can that tension force, and here it is become the braking force. The braking force is what? We know the braking stress is what? The braking force correspondingly division by area. And hence we can write that braking force as braking stress into area. That is what is mr omega square. Our aim is to find what is omega square. So that is the braking stress into area, that division by mr. So omega take the value as equal to root of the braking stress into area by m into r. What is the value of the braking stress? So that is 4.8 into 10 raised to 7 into the area as a 10 raised to minus 2 into 10 raised to minus 4 by the mass as a 10 kilogram into the radius as a 0.3. So that is a very important concept. So on solving, you get the value. So that is equal to 48 by 3. So that is equal to root 16. And you get the value for omega, that is equal to 4 radian per second. A good simple concept. Number 24. One end of a straight uniform 1 meter long bar that is pivoted on a horizontal table like this one. It is released from rest when it makes an angle of 30 degrees from the horizontal figure. Its angular speed when it hits the table is root n second raised to minus 1, where the value of n is. So at first we have to consider the concept as the change in potential energy there, that is converted into the kinetic energy. And here the rotation. So how we can find the potential energy? So you can just concentrate the center mass there by considering that one, and this is the height there, that is h making an angle theta. So that is a sine 30 is equal to that h division by the hypotenuse as L by 2. So h is equal to L by 2 sine 30. And hence we can say the potential energy is mg into h as L by 2 sine 30. That is utilized for increasing the kinetic energy as half into I into omega square. So our aim is to find what is the value of omega. But keep in mind, we can substitute it for that is sine 30 as 1 by 2 half into the moment of inertia for rotation of the rod, that is nothing but equal to I is equal to m into L square division by 3 into omega square. There 1 by 2 cancel, 1L cancel, cancel. So you get the value for omega square is equal to, that is equal to 3 by 2 into G by L. So omega take the value equal to root of That is equal to 3g by 12. You can substitute the value as a 3 into 10 by 2 into the length as 1. So 30 by 2 as a root 15. Then the value of n is what? 15. So here it is root n. So n take the value as 15. The last question, but a good question. The distance x covered by a particle in one-dimensional motion varies with the time ts. X square equal to 2t cube plus 2bt plus c. The acceleration depends on x as x raised to minus n, where n is an integer. And keep in mind here a, b, c are not, a, b, c are just constants. So don't confuse with the acceleration term as a. So we needed to find what is the value of n. Look carefully. So it is given as x square equal to at square plus 2bt plus c. So we can just differentiate. With respect to x, we can say that 2x into dx is equal to 2at into dt plus 2b into dt, and is a constant, so it becomes 0. So we can say that, we can take that dt, so it becomes 2x into dx by dt equal to 2at plus 2b. The dx by dt is v, and 2 cancel. So we get the value x into v, that is equal to at plus b. So Vx is equal to at plus b. So we can again just differentiate with respect to x. So we can say that. So x into dv with respect to x plus v into, as a dx by dx, they cancel, equal to a into dt by dx. So here, you know, that b become 0. So suppose we are multiplying by v. So you get the value as v dv by dx into x plus v square equal to, here dx by dt become v, and hence that v cancel. We get the value as a. And we know the concept as v into dv by dx. That is nothing but our acceleration. Don't confuse, so it is represented as a dash. So a dash x plus v square equal to a. So a dash x is equal to a minus v square. But we know the value for v square. V is what? So we can easily find the value for v from that one. So v is equal to at plus b by x. So at plus b by x, the square. So a dash x take the value equal to crossing ax square minus at plus b the whole square, that division by x square. So a dash x is equal to a into, what is the value of x square? So that is equal to a t square plus 2bt plus c minus at plus b square by x square. You just distributing, you get the value as ac minus b square by x square. So that is a dash x. Our aim is to find a dash. So that is ac minus b square by x cube. So here we can say that acceleration is proportional to 1 by x cube. So the proportional to x raised to minus 3. So we can say that n take the value as 3. A good question from motion in a straight line. So students, we analyze the 25 questions of JEE Main 2020. So we can observe one thing. There is a presence of one question from each chapter. So The most of the questions got a level higher than other entrances. So try to do maximum good questions, then you can get maximum rank in NEET examination. So God bless you. Take care.